There are only green pens and blue pens in a box. There are 3 more blue pens than green pens in the box. Therefore, I'm going to let green pens be the letter X. And as I know there's 3 more blue pens, therefore blue pens in algebra will be X plus 3. And as there's only green and blue pens in the box, therefore in total, the number of pens in the box is going to be X plus 3. Well, X plus X, that will simplify to give us 2X, and I've still got plus 3. There are more than 12 pens in the box. Simon's going to take at random 2 pens from the box. As he's taking 2 pens, therefore we know it's without replacement. We are told the probability that Simon will take 2 pens of the same colour is 27 over 55. And we're asked to work out the number of green pens in the box. As Simon takes 2 pens, we know in probability you must do the first pick followed by the second pick. So on my first pick for Simon, he's got 2 options. He can either get a blue pen or a green pen. The probability of getting a blue pen on the first pick, we know there's X plus 3 blue pens in the box. So number of successes is going to be X plus 3. We always divide by the total number of pens in the box, which we know in this case is 2X plus 3. The chance to get a green pen, we know there's X green pens to start with. So the chance to be successful is going to be X. And it's going to be out of the total number of pens in the box to start with. In this case, 2X plus 3. As he picks 2 pens, I now need to have my second pick. If he got blue the first time, he can still get blue or green the second time. And if he got green the first time, he can still get a blue or green pen the second time. On our second pick, the denominator is always going to be out 1 less because we know there's 1 pen gone from the box. So as there was 2X plus 3 pens to start with in the box, subtracting 1, that will give us 2X plus 2. So the probability on each denominator on the second pick will be out of 2X plus 2. To work out the probability of getting a blue pen on my second pick, well, follow my branch. Here, if I got blue the first time, there was only X plus 3 blue pens to start with. So chance of getting blue again, as there's now 1 blue gone, therefore it's going to be 1 less blue. So as was X plus 3, now it's now only going to be X plus 2, out of again 2X plus 2, because there's still 1 pen gone, which is the blue from the first pick. If I got a blue pen in my first pick, has the number of green pens been affected? No. So there's still X green pens in the box. But again, it's out of 2X plus 2, because there's still 1 pen gone, which in this case was the blue. If I got green in my first pick, has blue been affected? No. So there's still X plus 3 blue pens in the box. But again, it's out of 2X plus 2, because there's still 1 pen gone from the box, which is green. If I got green in my first pick, has green been affected again? Well, yes. So there's only X green to start with. 1 less will be X minus 1, because the 1 pen gone in this case was green. As we're given the probability that Simon will take 2 pens of the same colour is 27 over 55. Well, to get 2 of the same colour means I have to get blue first, followed by another blue pen. And if we go along a branch, we multiply. Or another way to get 2 of the same colour is I could have got a green pen first, followed by another green pen. Again, if we go along a branch, we multiply. Hence, the probability of getting a blue pen, followed by another blue pen. If we go along a branch in probability, we multiply. If you've got 2 terms, always place that inside single brackets. So it's going to be X plus 3 over 2X plus 3. That's the chance of getting blue the first time. Multiplied by X plus 2, multiplied by 2X plus 2. That's a chance of getting blue in the second pick. Or in probability means to add. So we're now adding the probability of getting a green pen followed by a green pen. Again, if we go along a branch, we multiply. So if we've got a single term, just write that as X. Or if you've got 2 terms, put that inside single brackets, 2X plus 3. And then we're multiplying by, if we've got 2 terms, always place that inside single brackets. So X minus 1 multiplied by, on the bottom, 2X plus 2 in brackets. And we know that must equal to 27 over 55. I should now notice that I've got a common denominator for both fractions, as I've got in brackets 2x plus 3 multiplied by in brackets 2x plus 2. Hence, I can write as a single fraction, expanding my double brackets, I know that 2x multiplied by 2x will give us 4x squared. I know 2x multiplied by positive 2 will give us plus 4x. I know positive 3 multiplied by 2x will give us plus 6x. And my last term, 3 times positive 2, will give us plus 6. Expand my double brackets from the first fraction. Here I've got x times x will give us x squared. I know x times positive 2 will give us plus 2x. I know 3 times x will give us plus 3x. And 3 times 2 will give us plus 6. Expanding my single bracket, I know whatever's directly outside I multiply by each term directly inside. So x times x will give us x squared. And x times negative 1 will give us negative x. And it's still equal on the right-hand side to 27 over 55. Collecting like terms on the top of my fraction. Here I've got x squared plus x squared. They're like terms as they both end in x squared. So one lot of x squared add another one lot of x squared will give us 2x squared. Collecting my single letters of x, here I've got 2x plus 3x. Subtract x. They're all like terms, they all end in single x. Well, 2x add 3x gives us 5x. And 5x subtract single x will give us plus 4x. And I've still got plus 6, my number term on the top. On the bottom, again, collecting like terms, here I've got 4x squared, no other term ending in x squared. I've got 4x plus now 6x. That will simplify to give us plus 10x. And I've still got plus 6. And again, on the right-hand side of my fraction, it still equals 27 over 55. As I have a fraction equal to a fraction, I can now cross-multiply. Expand the single bracket on the left-hand side. Whatever's directly outside a single bracket, I multiply by each term directly inside. So 55 times 2x squared will give us 110x squared. 55 times positive 4x, that'll give us plus 220, lots of x. And 55 times positive 6 will give us plus 330. On the right-hand side again, expand my single bracket, I multiply the term directly outside by each term directly inside. So 27 times 4x squared, that will give us 108, lots of x squared. 27 times plus 10x, that will give us plus 270, lots of x. And 27 times positive 6 will give us plus 162. I should now notice I'm going to get quadratic in terms of x. As I have more positive x squared on the left, I'm going to bring every term across the left-hand side to get my quadratic equal to 0. On the left-hand side, 110x squared subtract 108x squared. That'll leave us with positive 2x squared. 220x subtract 270x. That will simplify to give us negative 50x. And 330 subtract 162 will give us plus 168. And on the right-hand side, all this will cancel. Hence, I'm just left with 0. As I'm solving a quadratic, as I want to find the values of x, I can see all three terms here are divisible by 2 because they're all even. Therefore, to make my life easier, I'm going to divide all three terms by 2, and it does not affect my solution one bit at the end. So 2x squared divided by 2 will give us x squared. Negative 50x divided by 2 will give us negative 25x. And 168 divided by 2 will give us plus 84. And that's still equal to 0. As I have three terms, a quadratic in x, therefore it's going to factorize into what we call double brackets. As the quadratic starts x squared, I know each bracket will start with single x, and it's still equal to 0 on the right. I want to find two numbers that multiply to give us the number term, in this case, positive 84. And the same two numbers must still add to give us the number in front of the single letter of x, in this case, negative 25. As my number term is positive, and the sign in front of my single letter is negative, therefore the signs must be both negative. The only pair that will multiply to give us 84 and add together to give us negative 25, in this case, going to be negative 4 and negative 21. As we're solving, we now place each single bracket equal to 0. If I put x minus 4 equal to 0, well, opposite minus 4 goes across an equal sign, changes sign. Therefore, one solution is x equals positive 4. Put my other single bracket equal to 0. Well, the opposite of minus 21, if it goes across an equal sign, changes sign. Therefore, x equals 21. So when you solve a quadratic, you get two solutions. But here I can only have one solution. We are told in the question there are more than 12 pens. Hence, in this case, x must equal to 21.